We can use 4D simulations to identify opportunities to improve our construction workflow. For example, in this simulation, you'll notice that as we're adding structural elements to the project, they're coming in at entire floor levels at a time. All the columns for the floor level come in, then all the beams for the floor level come in, and finally all the joists for the floor level come in at the same time. While this behavior is common in many 4D simulations, it isn't very realistic because there's really no need to wait for the entire floor areas worth of columns and beams or joists to be put in place before you can start on the next operation. A more efficient strategy that's often employed to improve the schedule is to subdivide the building into separate regions. Then to plan the work with crews finishing up their tasks in a specific area and then moving on to the next area, freeing up the first area for another crew to begin the subsequent tasks. By layering the tasks of several different crews and setting up parallel workflows that track each other, we can often greatly improve the overall schedule by reducing the amount of waiting for prior tasks to be completed. This strategy is known as location-based scheduling, and we can work with Revit and Navisworks to implement it on our building project. Let's see how. First, let's return to Revit. Let's divide our building project up into 3 different zones. Let's switch to a floor plan view, and we'll call the region between grid lines A and D Zone A. Between D and E, we'll call Zone B, and between E and H, we'll call Zone C. To implement a location-based approach, we'll adjust our task timeline. Breaking any larger tasks that cross over several zones into 3 separate tasks. For example, for the first floor columns, we have task 120A, 120B, and 120C for level 1A columns, level 1B columns, and level 1C columns. And we've also broken the durations down. So rather than a single duration, we have 3 smaller durations for each of those different subtasks. We'll use these new task IDs, 120A, 120B, and 120C, to link the appropriate elements in our Revit model to the location-specific tasks. Let's return to the Revit model and see how that's done. To assign the elements in our building model to these new location-based tasks, we'll select them. For example, these structural columns will be included in Zone A. We can filter to select only the structural columns. And then over in the Properties palette, change the 120 task ID to 120A. Similarly, we can select the structural columns in Zone B, filter, selecting only the structural columns, and change those to 120B. Finally, for the last group, we'll again select, filter, and assign these to the task ID 120C. We can use a similar procedure for selecting beams, joists, and other elements. For example, to select the beams, let's switch to the ceiling plan. We can drag to select many elements, filter, and this time choose the structural framing, the girder type. In the Properties palette, we'll change all these, so rather than pointing to the single task, 130, we'll point to 130A for this zone. And finally, we can grab the joists. We'll again select, filter, this time selecting the joist structural framing elements. We'll go to the Properties palette and change those to 140A. Using these same steps, we can select all of the building elements that we'd like to assign to location-specific tasks from the building model on each of the different floor levels and assign them to appropriate task IDs for Zone A, Zone B, or Zone C. With our 4D task ID parameters updated, we can now return to Navisworks to link our updated building model to the new task timeline. Let's return to the Export to Navisworks view so we get all of the building elements. We'll again go to the Add-ins tab, choose the Navisworks file exporter, and give our new NWC file a convenient name. Once again, all the building elements will be exported in the NWC format, and we can switch back to Navisworks to import this updated model. In Navisworks, let's append the updated building model, choosing Append, choosing the NWC file, and saying Open. Then we can delete the old model. We'll also need to update the tasks in the Timeliner tool with our new task timeline. To do that, let's start by deleting the old tasks. We'll go to Data Sources, delete the old data set, then add in the new data set. It's a CSV file, and we can choose the Lesson 2 Timeline Part 3 to import it. Once again, we'll be asked how to map the fields between the Timeliner columns and the field names in the CSV file. We can say OK to stay with the same mapping. We'll choose the data file and say refresh the data sources, rebuilding the task hierarchy. When we return to the task tab, you'll see the new tasks are in place, but once again, we'll need to update the search sets to have one for each of the different task IDs that we'll be using, and then reapply the task linking rules. Let's open the Sets pane, and you can see that we've added new search sets for each of the different task IDs. So in addition to 120 as one of the task IDs, we have a search set that'll find everything for 120A, 120B, and 120C. For 140A, 140B, and 140C. With these new sets in place, we can reapply the task timeliner rules, say apply the rules, close up that window, and when we scroll over, you'll see that we have a new set of attachments linking the tasks to search sets containing the building elements that apply to those tasks. Let's scroll back to the left. We'll close the Sets pane, return to the Simulate tab, and verify our settings. Once again, it's 1 per day, 60 seconds for our playback duration. Looks like those are all fine. We'll say OK. And now when we run the simulation, you'll see the impact of breaking things down into different location-based zones, where Zone A comes in first, the elements in Zone B come in second, and finally the elements of C come in last. Similarly, on the second floor, the elements in Zone A come first, the elements in Zone B enter second, and the elements in Zone C enter last. When the 4D simulation is completed, we can see that we've managed to significantly improve the overall schedule for our project. The completion of the project is now at day 140 compared to day 172 in our previous version of the schedule, and we're actually able to complete the project by May 13th as opposed to June 14th, a very significant savings over the term of this relatively short project. We can step through the 4D simulation again, looking for opportunities to further improve the schedule by identifying areas where tasks are waiting on other tasks to be completed, and test out new sequencing to see if we can find additional opportunities to improve the flow of the work.
Other such opportunities to improve the flow of the work would be to divide our slabs into regions matching our pour sequence. Let's start by doing this to our slab on grade. We coincidentally also added some slab edges to this. Here we have our slab. Let's find a convenient view in which we can divide the parts. We can select intersecting references to access the grid lines which mark the zone separations. We recall it was grids D and E that defined our locations. We first see a preview of the split, then we can accept the edits. Let's repeat this process for the slab edges. First, selecting them, then clicking Divide Parts. Again, choosing the same grids as references. Back in the view, we can confirm that those part splits were made. Let's examine how our schedule accounts for this location phasing of the tasks. We have 110 A through C for the edges and 111 A, B, and C for the slabs. Now we know that we need to assign those to the construction type property 4D task ID that we have already in our project. I will carefully go through and assign the parts according to the location in which they fall. I should note, actually a scheduler might very well correct us later by pointing out that actually in the field the edges and the slab within a certain grid zone would be poured at once and not separately. Now I'll export out my NWC, ensuring that the options allow to convert parts. And here, back in Navisworks, we see that our parts came through. Now let's get down to attaching the model geometry to these tasks. Navisworks offers us an auto-attach command where we can directly map all elements with the matching 4D task ID to those tasks with the same ID. Finally, we will run our simulation to see the results of this model disaggregation upon our construction sequence, seeing how it's added that much more detail to reflect the tasks as they'd occur in the field.